All right, so in this one, repopulate, it's a void method. I don't have to return anything. I want to visit every single item in the grid. And I don't really care how I get there. So I'm just going to do a row major loop. It is going to matter in part B, but part A doesn't really matter how we get to where we're going. We just got to go to every single spot. So let's go to every row index. And then let's go to every column index. Now, when we get there, we're going to generate a random number. And it's got to go from 1 to max. We don't know what max is, but we don't really care. Oh, man. All right. But even once we generate this number, then we still have to kind of make some decisions about it. So let's see. I'm going to make a random number. Hopefully you remember your random number generator. Just math.random. Multiply it by max. And then add 1. All right. That makes it go from 1 to max. All right. But what if that number doesn't do the things that they want it to do? Like, one of the things they want it to do is to be divisible by 10. So what if that number is not divisible by 10? So in other words, if I took its modulo with 10 and I didn't get 0, okay? Or what if it didn't do the other thing it was supposed to do? The other thing it was supposed to do was not be divisible by 100. So what if it was divisible by 100? If either of those things were true, I would need to generate that same type of thing again. So in other words, I'm going to copy all that, but notice I don't want to redeclare it. I've already declared rand as an integer, but if it doesn't meet their specs, I have to do it again. But what if it still failed these tests? Then I'd have to do it again a second time or third, depending on how you look at it. What if it failed again? Then I'd have to do it a fourth time. What if it failed again? There's no end to that in sight. So I really shouldn't have written the word if there. I should have written the word while, right? I'll just let this thing keep doing this until I get a random number that meets all of their specs. So in other words, it meets the spec of going from 1 to max, being divisible by 10, and not being divisible by 100. Now, in fact, you don't really need to write this out here. You could just put something like 0. What that would do is it would basically just force it into the while loop. Like, it would guarantee the first run and then let it keep running until it gives you the kind of number that you want. Then we're ready to go ahead and add it to our grid. And if we hit run, I don't really know what we're going to get, but we should see every number end in 0, and we shouldn't see any double zeros. And we should see, like, so for me, I don't want to go above 440, but you should see some numbers kind of getting close to 440. And we don't see any zeros. Yeah, I mean, this looks pretty good, okay? All right. If I ran it again, it's going to make some different sizes for you and whatnot. All right, part B of this problem wants to know how many columns are increasing. And their definition of increasing is going to allow for ties. So that's important to note. Now, in this problem, I said it didn't really matter what order you accessed, like rows, columns, whatever. In part B, it kind of does, because in part B, I'm going to actually want to pick a column first and then pick a row. And the reason is I want to pick that column index and get stuck there and then go through all of the rows that belong to that column. That way I can answer these column-specific questions. There's also a counter method. So I want to go ahead and count how many times this happens. Now, typically, when we do questions like this, like increasing, decreasing, it's often like a Boolean question. And we say something like, if we find a violation to their claim, we can return false. If not, we can return true. I'm going to have something like that in the internal part of this. Like, inside here, I want to ask a question. I want to perhaps go one row up in the matrix, like row -1. And their claim is that that number should be less than or equal to the number below it. Okay. Well, here's the deal. A couple things, right? If I'm going to access one row up, I better start at row 1. And if they're going to say less than or equal to is what should happen, what I often do in questions like this is I think, well, let's take the opposite approach. What if it doesn't happen? And what I'll say is I'm gonna claim right up front. I don't know why I wrote int boolean. I'm gonna claim right up front that this thing is increasing like they want it to. But if I can find one instance where it's not increasing, so like it's violating that, then I'll change it to false. And after I get through that entire column, I'll just ask about that variable. If it's still true, then I'll go ahead and count that particular column. And then if it ever switched to false in that middle process, I won't count that column. It says I should get 1, 2, 4, and that's what I got here. All right, so we're counting the number of increasing columns. Okay, so pick a column, any column, right? Assume that it is an increasing column. Try to prove otherwise. If you never prove otherwise, go ahead and count it. That's the basic idea here. And you do that process for every column in the matrix. And in the end, you'll know how many of them were increasing columns.